All right. Thanks for coming. First of all, my name is Raja Rao. So I'm one of the leading evangelists for Lightning Components and Lightning App Builder. Today I'm going to kind of talk to you about how to build end-to-end apps. I'm not going to go into the too much of weeds into code itself. I don't want to make you coding experts right here. But I really want to kind of emphasize why you should care about Lightning Components, and also what it is. So what it is and why, more than how. So safe harbor statement, Salesforce is a publicly traded company. So if you see or hear anything any futurist statements that I may make, so please make your purchasing decisions based on whatever is available today rather than whatever I make today. And I will be making a lot of futurist statements. Again, my name is Raja Rao. I'm the developer evangelist for Salesforce. You can always find me on my Twitter handle here. Okay. So everything about my talk today revolves around one thing, which is components. Again, as I said earlier, I'll be talking about the what, the why, as opposed to how are the mechanics of it. Okay, there are lots of books around there. If you go to the library, there is a Lightning Components book, which is like a 300-page book. You can learn a lot about it from that book. And we also have quick starts. So how many of you done quick starts, Lightning quick starts here? Okay, I see only small percent, about 20-25%. So the rest of you, after this, you should definitely go to the quick start area and then do Lightning Components quick start and get a kind of a taste of what it is. Okay, let's start with the what. What is the component? So in the JavaScript world, in the UI development world, it's all kind of something totally new, right? So we are launching it today. Very few other companies are doing it. It all sounds like something completely out of the world. But the truth is, in the real world, it already exists. So take, for example, a car. So car analogy. So the car itself is not a single monolithic product. It has multiple components in it. So for example, it has a tire, it has brakes, it has mirrors. So all these are components. So in the Lightning world, the Lightning app is the car, and Lightning component is a tire or a brake or a mirror. So whenever we say component, you should think of these tires or brake pads or mirrors. Okay, and so let me show you how it looks in the code. So how many of you are familiar with jQuery here? Everyone? So you all know how easy it is. You just add a one-liner, and then it just works. You can just use it. But the problem is you still need to build your own apps. So you got a library, but it's still not good enough. You still build your own apps. So what we want to do is we want to go to the world where we want to evolve to a world where you just add one-liners, and automatically entire UI, entire thing with full functionality shows up. So for example here, if you're building a car application, so you just going to say, brakes component, tires component, mirrors component, engine component, and it just starts to work. It just starts to show up as a UI. So not just a library. So that's the world we want to evolve into, right? So that's exactly what a component is. So in the code-wise, it should all look like a single-line statements rather than entire JavaScript and CSS. Now, CSS and JavaScript are still there. They're just hidden away, right? They're just hidden away, and the component framework enforces rules like lane, like a lane system in the US. So everyone follows that lane. So we are kind of enforcing a proper way to build your application and divide them into components. Let's take a look at why. So why? So why are the benefits? What are the benefits of building it like this? So first one is, again, going back to the analogy, if a tire pad wears out, or a brake pad wears out, or a tire breaks, right? You don't really, replacing them is super quick and easy. You don't really spend too much time. Second one, if a component breaks, replace just that component. So especially if you're coming from the Visualforce world, you will know that a lot of times when there is a small problem, you still need to make a major surgery to it, right? So for example, in the car analogy, if a brake pad wears out, you don't go and then touch the engine or a car seat or any such things, right? You just go and then replace the brake pads. So the idea is when you have components, well-defined components, if something wrong happens, you can very easily replace them. Third, parallel development. So when you start thinking about components, it becomes a lot easier to develop. It becomes a lot easier for your product manager to assign responsibilities. It becomes like right now, it's going to be like UI team and then server team, right? But in the UI team, there are different people who are working on different pieces, especially if it's a really large, complicated application. So if you define a component, then product managers and engineers and QEs, everyone will be aware of their responsibilities. And if something breaks, you know exactly whom to go to get it fixed. Fourth, build for specifications, also known as build for specs. So what happens is once everyone starts to follow the rules, or if there is some kind of a standard, all of a sudden, you know, different companies can manufacture to that standard. So for example, here there are 2 different brake pads from 2 different brands. So now a customer can go and then choose whichever brand he wants. Right? It becomes very, very simple. So when Apple, for example, makes iPhones, they don't give out iPhones to the phone case manufacturers. They just give them specifications. They just tell the width and the height, where the camera is, you know, where the buttons are, just the specs. And using that spec, all these manufacturers makes, you know, millions and millions of components and different brands, right? And they will all work just fine. So that's the benefit. That's the fourth benefit of, you know, thinking in components. Fifth one, you can customize it like never before. Like it's like some serious customizations. So for example, like this, that's another thing you cannot really do in Visualforce world, because everything is monolithic, which means a lot of pieces are all interconnected. So now you cannot just replace something and then put something in between very easily. So that's another big problem with the, you know, monolithic designs. Sixth benefit. So once you have, you know, once everyone kind of comes and then builds these components, you all of a sudden start to see hundreds and hundreds of ready-made components. So right now, how we are using this jQuery or other libraries, you should start, you should start to see hundreds or hundreds of like components where you can pick and choose. It becomes very easy for people to buy and also sell. You can make money off of it. You know, if you're an ISV, you can build a bunch of really nice, nicely working components, and you can start selling it. With, you know, all these 6 benefits ends up with something dramatic, which is you can build a bunch of components, and some company may be using those set of components to build a car, and some other companies may start building, you know, use the same set of components and build a robot, right? Some transformational things. So that's why this transformer is here. So you simply cannot do these kind of amazing customizations or use it you know, in a incredibly different ways if you build a monolithic app. That's why components are so important. That's why we're all stressing, you know, we should all build components as opposed to just building JavaScript and, you know, get your job done today. Because you'll be doing, every single one will be doing the same thing over and over again. It's just not efficient. We want to go from today's world to the transformational world. So now, imagine that we all build this, we build these apps, but we still need to figure out, okay, where the development happens and where the distribution happens. So in the development, in the car analogy world, you know, there is a car manufacturing plant, and within Salesforce, we have a developer console. You can also use Sublime and other things, Maven's Mate, for you to build locally and then push it back up. And then the other part, you can't just build it, right? You need to be able to sell it, you need to be able to service it, you need to be able to test drive it. You need to be able to allow customers to test drive it. That's where our Lightning App Builder comes into picture, okay? So Lightning App Builder is a place where people can come in and then test drive it without actually running your components inside their application, right? So they don't even have to they don't have to put your applications inside their application at all. They just can test drive it. And also they can customize it. So let's take a quick look at how it would look. So in the top left here, when you build all these components, one of the things you'll also build is, you know, you create an icon for each of the components. So all those icons and the names will start to show up in the left-hand side. So the standard components are components that are built by Salesforce itself. And then at the bottom, you have custom components. So these are all the components that your organizations build, right? You can, within your own organization. At the bottom is very interesting, which is App Exchange components. So now, ISVs and others can start building their components, and then it will all start to show up in our app builder. So it's kind of starts to act more like a app store, right? So it's like a component store from Salesforce, right? And people can come in, and then they can click and drag, and then they can start customizing over in the middle. We call it a canvas area, and test drive it and see how it works. Does it load faster? Does it have any flickering going on? Does it look good? And all those kind of things. And on the right-hand side, you see there is a little bit more customizations you can do. So again, you can select one of the components, and you can do a lot more customizations using the app builder. So okay, what's available for Dreamforce as of today or tomorrow? So the Lightning Components development or the manufacturing, that is in beta, which means any org that's going to have like Winter 15, they all will have Lightning Components enabled for them as a beta feature. Okay, whereas the Lightning App Builder itself is in pilot, so which means Salesforce needs to enable it for you, right? So it's all there, but it's not enabled for you. And if you create a brand new org today, you will actually see Lightning App Builder enabled as of today itself. It's actually, if you go to the quick start area, we ask you to build brand new orgs, because the org that, the instance that you will be directed to, it already has Winter 15. For the rest of you, you will start seeing this Winter 15, released onto your instances and orgs over the next coming weeks. And one thing is not there right now is that, if you build something, it doesn't really show up as it is right now, because the Lightning App Builder component is still in pilot. But that doesn't mean that you cannot, install it. So you can still create a unmanaged package or managed package, just like you would do in Visualforce world. You can do the same thing, but it's just not there, shows up in this visual editor for admins to go and then configure and then test drive and so on. So now you saw the components, where it is manufactured and where it is, where it is customized and test driven, and also understood all the benefits. But where do they run? Components can live in 3 different places. First is what we call as a standalone app, which means it has its own URL. So you can build a little component, and it gets a URL like this. The second one is inside Salesforce 1. So you can build a Lightning component, and you can run it inside Salesforce 1, just like you would do you would run a Visualforce page. But the difference is, unlike Visualforce page, this doesn't use iframes, because Salesforce 1 itself uses Lightning components. So Lightning components, in other words, is in production for at least a year or 2 years now. So when you build your own custom component, it will run exactly as yet another component inside Salesforce on mobile app. So this kind of opens up a whole new possibilities. One of them is what we call as Lightning extensions. So what it does is, you can say now, hey, Salesforce, I don't like this particular component that you created. I want that to be replaced with my own custom component. So for example here, this doesn't really give you an example. You should definitely go to the demo booth area, where you will see all these list views, all these kind of rectangles. They're all different components. Each one of them are components. So this is a component, this is a component. So within Salesforce One mobile app, there are like hundreds of components. So you can say, okay, I want to replace this 99th component with mine. So for example, you may be looking at an accounts page where you may be seeing, let's say, geolocation, right? So just the latitude and longitude numbers, but doesn't mean anything, right? But that itself is a component. So you can build a Google Maps component and embed that rather than just seeing the numbers, right? So in fact, if you go to some of our partners, some of the early partners who are actually building these things, like Squid, Clarisoft and others, they will show you some really cool components where they make some amazing modifications to Salesforce on mobile app. And also you can add some additional stuff like this 4th tab here. So imagine, you are looking at an accounts page or some other opportunities view of some company, then you can add an additional tab where you can see their stock price or RSS feed or something else, or their competitors. So you can add some extra stuff to our mobile app as well. So the last thing I want to show is like it's not a proprietary thing, and the biggest thing that we are doing with this Lightning Components launch, Lightning Components Frameworks launch, is that Salesforce now puts all the Salesforce developers on par or above par with all these hyperactive companies, mostly in the consumer world, like Google with their Polymer, Facebook with their React, Twitter with their Flight. So for example, Facebook uses React, which is also a component-based framework in production. And Twitter uses Flight, again, another component framework in production, right? So with this, you will actually be building the same kind of things, the next generation, next evolution of this whole UI development framework, within Salesforce. So the next up is Visualforce versus Lightning. How is it really different? So you saw the benefits, but the challenges with Visualforce is it was built, before mobile era became popular, right? So one of the problems is it runs in server side, which means let's say a user checks a checkbox and saves it. That just the information has to go to server, and the server needs to create a brand new HTML page with a checkbox checked and send it back all the way from server to the client or the app. So in the mobile world, it is like literally like driving a truck in San Francisco. There is not enough resources, there is not enough space, not enough memory, and also you will be using your mobile app not inside your company. You will be using it in a shuttle bus or in a train or something. And your customers expect it to work just like any other mobile apps. So if you want to build, if you want to make your customers happy, you really need to do either use Visualforce and use AngularJS or something else, or you can use Lightning and build everything on the client side and do it that way. So the second thing is, as I mentioned earlier, it uses iframe in Salesforce One mobile app, which means it doesn't have access to any other components. It just in its own world. So you cannot really do any dramatic customizations that your customers might be asking. That's the main, kind of the main benefits of the difference between Visualforce and Lightning. Let's take a look at quickly the how parts of it. So again, each component actually is just a regular HTML, JavaScript, and CSS. And they all kind of interact with what we call as events framework. So what it allows you is you should no longer bind or weld two different components together. You should just build your own component and say, okay, my component sends this information and this component receives this information. It kind of almost works like you have a satellite that is sending all these GPS signals, and there is a GPS device. The GPS device is just listening to it and displaying the data. So there is no real hard wire connecting to it, right? There's just a signal going on between each other. So that's really the idea between components design. That's really the idea also of events. And also they can all be stacked. So they can be stacked however you want. It's literally like a Lego piece. All right. So thinking in components, I have just one slide. Main thing you should think about is at a component level or the interface level. In the Java world, in the Apex world, you probably have heard of like build to interfaces, right? Not build to the class itself. You always build an interface and you program, everyone else should be programming to the interface. So that's the same idea in the UI, in the JavaScript UI world. And you should kind of think about like what attribute should it take? What should be the receiving points, and also what should be what kind of events it needs to listens to, and what kind of events it should fire to the other components. So that's all you need to think about. And then you build your JavaScript, CSS, everything inside it. Okay, so I'm going to quickly talk about an example app. It's actually from our developer guide. So you can find it from our library out there. It's also available online. So online, you should go to developer.salesforce.com/lightning. So you will see the book, online version of the book as well. So this is a really simple expense tracker app. So it has 4 different parts to it. The first one is the expense reporting form, and then total expenses, number of expenses, and also the list of expenses itself. You don't see the list of expenses here, but there are more than one expenses here. So let me quickly show you how it looks. So this is just an example of a standalone app. Okay, so in your browser, in your app, it might look like this, but in your tablet, it's going to look like this. So these are all the list of expenses, and I can basically add a new expense, and it shows up at the bottom. And I can create a reimburse. I can select a checkbox reimbursed, and it actually gets saved in the server. So now that you know how this thing looks, let's see how it is built. It can be built using Lightning components. I'm going to, again, not going too much into the weeds of the code itself. I want to just give you the highlights of how it works. So first of all, we have to divide your application into multiple components. So you could have divided it into 4 different parts, and there are lots of there are lots of design principles of how you should define. I also encourage you to check out Facebook React's thinking in components. So they have a thinking in components section in Facebook's React's documentation. So I encourage you to do that. So basically, in this particular case, we are divided into 2 different parts. So the first one is a form component, and then the second one is a list component. So let's see how this thing kind of works. I don't know if you guys can see it properly. So the initial flow. I think before I show this, I'll probably should show the expense, some of the little things in the developer console. So within developer console, if you have Lightnings enabled, you will start seeing kind of these kind of extra sidebar for every single app. So let's take a look at here. This is my expense tracker app, and you can see here I only have this thing as a form component here, and it has its own CSS. And there is a form component here. So this form component is a markup that we are using. This is like the HTML part of it. And then you have a component is what we call as a bundle. You will probably hear a lot of words called bundles. So bundle is because every component is not just a single resource or single file. It's literally made up of multiple parts, multiple files or multiple resources. So and you can access all of them from this sidebar. So a component, for example, has its own markup, and it has its controller, which is a JavaScript controller, right? So this is the one that listens to any kind of a user interaction. If a user selects a checkbox or entered something, so this is the one that binds to it. So it provides a 2-way binding similar to, for example, AngularJS, right? So we have more or less the same kind of one-to-one mapping between AngularJS and and other frameworks. And we also have helper. So if there is any JavaScript functions that you need that doesn't fit into the controller aspect of it, you can just put it in here. So this function, usually you will keep functions that also talks to the server-side Apex to get, to send and receive information. And then the style. So every single component has to have its own style sheet. So this particular editor enforces the word this before you can put it in for all of your CSS classes. So what happens is when at runtime, that this will be replaced by your component's name and also your company's namespace. So that way it kind of enforces the CSS to be encapsulated within your component. It doesn't affect someone else's components, right? So we are using it in our mobile app very strictly because we don't want people to come and mess with, change everything with the sales, conflict with some other component. So that's the form component, and this is the expense list component. You can see the .cmp here. So let me go back to the form component a little bit here. So see here this line here. So this is the line. Ignore that the word jam is just happens to be my namespace, and the EL is the expense list component that I have. So that's just the interface that it is exposing. It is saying that, hey, I need this I just give me the expense object itself, entire object, and then I will know how to display it. So all it does here, this particular component, the form component, is going to have an iteration. It just runs through the loop of all the expense records, and one by one, it just calls this component and says, hey, expense, take this and then show however you want to show. And expense component, then the list component then takes it over, and then that it displays how the how to display that particular list item itself. Okay, so it has its own controllers, and so you can also see, let me show the events portion of it, so you can kind of see how it is. I don't think I have it here. Or else I can just create a new one. I can't find it right there. So open new. Oh, I think I logged out or something. That's what the problem is. New lightning event. Okay, so yeah, I think I'm logged out. So I don't want to go to weeds again. So again, so you can create an event, and it just literally has one line in it where you can describe how the event works. Okay, now let me go back to my slides a little bit and kind of show you how the flow actually works when something happens. So this is the initial flow. So when the app itself loads, the Lightning framework actually sends an event called init event to every single component. And this event, I don't know if you guys can see it in the back. Okay, great. So this event comes to the form component, and the form component then sends to the controller saying that, hey, I got an event, I need to initialize everything. So this one happens to have a function called doInit function, and that function then sends to the form controller, form helper function, and that helper function then goes to Apex, and Apex says, okay, give me all the expenses. And the Apex comes back the list of list of expense items comes back all the way to the component itself, and then this component then runs the iteration tag that we showed, and it then sends it to the internal subcomponent, the expense list component. So you see the whole loop right there, right? And let me take it to the next step here. So new expense flow. So if someone creates a brand new expense, how does that work? So again, when someone creates a new expense and presses the submit button, it goes to the controller. So the form component, the two-way binding inside, not necessarily two-way binding, the handler from the form, the markup, has a controller function. There is a one-to-one mapping between the controller and the DOM itself. So that kind of event handler is going to send this information from the form.component, the markup itself, to the controller. And most of the times, controller's function is limited to just that, just listening and then sending it back. But then any kind of a server-side activity, it sends it to the helper function. So just refactoring going on there. So then it sends to the helper function, and the helper function actually makes call to Apex and to the server to create a brand new item. And once the item is created, it handles the event back. The event comes back here, and it goes to the component. And once the form list component gets the information that a brand new expense item is created, it just adds it. It again sends the new expense item to this list. And this list knows that, because of two-way binding, when it gets a brand new expense list item object, it just appends it to the tree, to the list of items. And the last one is the reimbursed flow. So you saw the checkbox in the child item. So the child item, again, when you press a checkbox here, again, that information goes to its own controller because there is a two-way binding. So, and this function in the controller, in the subchild, the child component controller, goes all the way back to the event, and it fires an event saying that, okay, I checked a checkbox. And this the load component, the form component happens to be the handler. It will be handling, okay, I'm waiting, if someone checks a checkbox, let me know. So there is a handler, and that handler then, again, goes to the controller to helper, and helper goes there and then saves the checkbox information back in this database. So this line ends right here, because we are not really, in this example, caring about whether the item was saved or not. But usually what you would do is you would have an AJAX call, and once the response comes back, you will handle it in the form component. So the interesting thing to note here is most of the server-side handling is all being done by the outer component as opposed to inner components. Right? So when you're thinking of components, you should think about whether this component needs to talk to server at all, or it should ask, I'm going to send you the event, and you handle it however you want. So when you are thinking of building components, you can build two different kinds of components: a component that talks to Salesforce, or just pure visual component, where it says someone else needs to give me all the information, I'm just display only. Right? Or if there is an event happens in the child component, I'm going to again give it back to you. You need to handle it. So you need to figure out what's the best way to divide your app, and how many of your components should really talk to Salesforce or the server. So one of the best practices is to limit all the components from talking to the server, but rather keep just going to have a design principle. Rather keep all the interaction between the component and the server to one of the higher up components, or the topmost components. So that way you don't have to keep the states and all the data in all these different components. Rather just always refer to one top component. Okay, so that's pretty much all I wanted to show you guys today. We just discussed what it is, why you should care, what is the difference between Lightning versus Visualforce, and I kind of showed you a little bit of an example of how a component code looks like. So we have lots of sessions today. So the ones that I highlight are at 4 p.m. and 5 p.m. Our core engineers will be talking about it. So they will go into much more details about it. And there is also a quick start. If you have not done it, you should do it. And I have lots of laptop stickers here. So I don't know if you can see it here on my laptop here. So come grab the stickers for your laptop after this, right away, if you can. And if you have any questions, ask me as well.